Hello, welcome to Pakibi TV. In this video, I will explain what calculus is all about. You can easily find explanations about calculus here and there. But in this video, I aim to provide a shorter and simpler explanation that really resonates with you. Calculus is essentially a computation that transcends the dimension of change. What is calculus? This is the question for this explanation. To clarify terms here, calculus is the same as differential calculus. I was confused about this when I was younger. First of all, calculus combines differentiation and integration. So what is differentiation and what is integration? Differentiation is calculating something that is finely divided, and integration is calculating the stacking of parts. Differentiation is carried out in this manner, and integration is performed like this. The question that arises here is this: what is happening within these complex calculations? The answer to this, as mentioned earlier, is that it transcends the dimensions of change. What do we mean by dimensions here? To show an example first, 1D refers to a line, 2D refers to a plane, 3D refers to three-dimensional space. Below that is 0D, which is a point. Going above that, we enter the realm of the logically imaginable. 4D adds another direction to 3D space. Einstein thought of it as adding the dimension of time. Mathematically, you can think of higher dimensions by adding more directions. When we talk about transcending dimensions mathematically, differentiation is the calculation of going down by one dimension, and integration is the calculation of going up to a higher dimension. Now let's focus on change. Why does calculus transcend not just any dimension, but the dimension of change? We already know simple calculations that transcend dimensions, like calculating the area of a rectangle, or calculating the volume of a rectangular prism. In area calculations, we multiply the lengths of line segments, that is 1D, to find the area, which is a 2D value. In volume calculations, we multiply the length and width to find the area, that is a 2D value, and then multiply that by the height, that is a 1D value, to find the volume, which is a 3D value. So even without calculus, we can to some extent perform calculations that transcend dimensions. However, we hit a limit when trying to find such areas. I'm talking about areas bounded by curves. Here, a curved boundary means that the height and area are changing. In other words, the area changes based on the rectangle. At this point, we use differentiation to find the length of a very thin line. This is the calculation of differentiation. Essentially, it's going from 2D to 1D. The length of this line changes. Then we collect these changing lengths to calculate the area. This is the calculation of integration. We calculate quantities in other dimensions that change in exactly the same way. To explain this more precisely and concretely, it would take too long, so I will explain it in another video. So you can say that integration is the reverse calculation of differentiation, and differentiation is the reverse calculation of integration. I've briefly explained the basic meaning of differentiation and integration as calculations that transcend the dimension of change. But as for how to actually perform these calculations, I will explain step by step in another video. If this video has been helpful, please hit the like and subscribe buttons. Thank you.